History of probability. Introduction. Probability theory or probability calculus is the branch of mathematics concerned with probability. Although there are several different probability interpretations, probability theory treats the concept in a rigorous mathematical manner by expressing it through a set of axioms. Typically, these axioms formalize probability in terms of a probability space, which assigns a measure taking values between 0 and 1, termed the probability measure, to a set of outcomes called the sample space. Any specified subset of the sample space is called an event. Filled square central subjects in probability theory include discrete and continuous random variables, probability distributions, and stochastic processes, which provide mathematical abstractions of non-deterministic or uncertain processes or measured quantities that may either be single occurrences or evolve over time in a random fashion. Although it is not possible to perfectly predict random events, much can be said about their behavior. Two major results in probability theory describing such behavior are the law of large numbers and the central limit theorem. History of probability. The modern mathematical theory of probability has its roots in attempts to analyze games of chance by Gerolamo Cardano in the 16th century, and by Pierre de Fermat and Blaise Pascal in the 17th century, for example the problem of points. 3. Christian Huygens published a book on the subject in 1657. 4. In the 19th century, what is considered the classical definition of probability was completed by Pierre Laplace. 5. Filled square. Initially, probability theory mainly considered discrete events, and its methods were mainly combinatorial. Eventually, analytical considerations compelled the incorporation of continuous variables into the theory. Filled square. This culminated in modern probability theory, on foundations laid by Andrei Nikolaevich Kolmogorov. Kolmogorov combined the notion of sample space, introduced by Richard von Mises, and measure theory and presented his axiom system for probability theory in 1933. This became the mostly undisputed axiomatic basis for modern probability theory. But alternatives exist, such as the adoption of finite rather than countable additivity by Bruno de Finetti. 6. Treatment. Most introductions to probability theory treat discrete probability distributions and continuous probability distributions separately. The measure theory-based treatment of probability covers the discrete, continuous, a mix of the two, and more. Filled square motivation. Filled square. Consider an experiment that can produce a number of outcomes. The set of all outcomes is called the sample space of the experiment. The power set of the sample space, or equivalently, the event space, is formed by considering all different collections of possible results. For example, rolling an honest dice produces one of 6 possible results. One collection of possible results corresponds to getting an odd number. Thus, the subset 1, 3, 5 is an element of the power set of the sample space of dice rolls. These collections are called events. In this case, 1, 3, 5 is the event that the dice falls on some odd number. If the results that actually occur fall in a given event, that event is said to have occurred. Probability is a way of assigning every event a value between 0 and 1, with the requirement that the event made up of all possible results. In our example, the event 1, 2, 3, 4, 5, 6 be assigned a value of 1. To qualify as a probability distribution, the assignment of values must satisfy the requirement that if you look at a collection of mutually exclusive events, events that contain no common results, e.g., the events 1, 6, 3, and 2, 4, are all mutually exclusive, the probability that any of these events occurs is given by the sum of the probabilities of the events. 7. Filled square the probability that any one of the events 1, 6, 3, or 2, 4 will occur is 5/6. This is the same as saying that the probability of event 1, 2, 3, 4, 6 is 5/6. This event encompasses the possibility of any number except 5 being rolled. The mutually exclusive event 5 has a probability of 1/6, and the event 1, 2, 3, 4, 5, 6 has a probability of 1. That is absolute certainty. Classical probability distributions. Certain random variables occur very often in probability theory because they well describe many natural or physical processes. The distributions, therefore, have gained special importance in probability theory. Some fundamental discrete distributions are the discrete uniform, Bernoulli, binomial, negative binomial, Poisson, and geometric distributions. Important continuous distributions include the continuous uniform, normal, exponential, gamma and beta distributions. Convergence of random variables. Law of large numbers. Filled square. Main article. Law of large numbers. Common intuition suggests that if a fair coin is tossed many times, then roughly half of the time it will turn up heads, and the other half it will turn up tails. Furthermore, the more often the coin is tossed, the more likely it should be that the ratio of the number of heads to the number of tails will approach unity. Modern probability theory provides a formal version of this intuitive idea, known as the law of large numbers. This law is remarkable because it is not assumed in the foundations of probability theory, but instead emerges from these foundations as a theorem. Since it links theoretically derived probabilities to their actual frequency of occurrence in the real world, the law of large numbers is considered as a pillar in the history of statistical theory and has had widespread influence. 9. Filled square. The law of large numbers, LLN, states that the sample average origin of probability. The theory of probability had its origins in games of chance and gambling. Probability originated from a gambler's dispute in 1654 concerning the division of a stake between two players whose game was interrupted before its close. The problem was proposed by a well-to-do gambler, the Chevalier de Mere, to prominent mathematicians including Blaise Pascal, who shared his thoughts with Pierre de Fermat. Filled square. The correspondence which ensued between the two mathematicians was fundamental in the development of modern concepts of probability. From a mathematical point of view, games of chance are experiments generating various types of aleatory events, the probability of which can be calculated by using the properties of probability on a finite. Thank you.